Hey guys, my name is Vivek Sharma and today I want to target to this problem, that's square root of the given number. So in this problem we want to calculate the square root of the given number, right? So if I have been given some number, I can see it's 4, it's returning by 2, right? So it's a midpoint of 2, right? So the basic intuition I can think of to apply the binary search, right? And to the binary search, if I apply, then I think it should be working fine. So let's go ahead and apply binary search first, and then we will go from here. Why I'm doing the 1? Because for 0 it does not make sense, right? We have to calculate the square root, so 0 can be misleading, so we want to try with the 1, right? And then right is x, and then let's do this traditional binary search. Left is less than equals to right. Let's go ahead and calculate midpoint, and that's left plus right minus left by 2. So this part is same as left plus right by 2, right? So yeah, this is same as this thing. If you are still not clear why I'm doing this, I will say that just go ahead and just search on internet why we do this, because this is just to avoid the the overflow exception, right? So not stack overflow but the general overflow exception. So if you will do this plus, starting point plus, if you are adding that, then you will be avoiding the overflow. Otherwise with this we might encounter the overflow problem, but I will not deep dive in this topic because here we are just doing the square root of x. But I will just leave it up to you. Just search on internet if you are just more curious how to do that, right? And then just search this, like if mid into mid is less than x, then what we want to do. So if it is then mid plus 1, we want to increase the mid, right? And else if your mid into mid is, if it is greater than x, then what we want to do, we want to shrink from the right hand side, right? Else they are equal. So just go ahead and return mid. That's it. So that's the very simple binary search algorithm we can apply to this to solve this problem. Now now here we need to fix couple of more thing as well, because we are doing mid into mid, so it can cause the overflow here as well. So let's do those x by mid. So if you can think of like x by mid and uh, so x by mid and this mid into mid, that's they are the same, but this is just make sure that we are not getting the overflow error, right? So that's why I'm doing this. So this algorithm will work for this, right? It will return the mid, so it will work for the perfect square. But if it is not perfect square, we want to return right. And the reason we are returning right, because it will always be upper bound, right? Square root will always be upper bound. And to prove case like this how it is be upper bound, I will say that just run couple of examples for 5 6 7 8 or other thing, right? And another observation is here, left is, I am not taking left is less than right, I am taking left is less than equals to right. And the reason to do that is because in some situations where left, right and mid, they all three are equal, right? If they all three are equal, or at least left and right, if they both are equal, we want to still decrease from the right hand side, right? And the typical case is 8. So in typical case 8, basically left, right and mid at one point they are becoming as 3, but the actual output is 2, right? If I don't do less than equals to, then the output will be 3 not 2, right? So I have to do the less than equals to 3, so at least we will get the right answer as per this problem. So that's this observation. That's I just wanted to explain that why I'm doing less than equal to here. I wanted to explain why I'm doing here to get rid of overflow problem. But if you are still having some problems, concerns, just feel free to just discuss, and then we can just course correct whatever it's needed. From the time complexity wise, basically it will be log n because it's the binary search, and binary search, if it works, basically we just keep dividing into the two parts and then keep searching, right? So it's always log n basically for the binary search. So when I say always log n means in this particular case, so but it depends case by case, but it will always be log n, but it can be n log n or log n or whatever the algorithm is there. But here we are just simply dividing and then just keep searching, so it will be log n here. So TC means time complexity, and let's say this is log n, where n is the given number, right? So space complexity is here O of 1, right? O of 1 means I'm not taking any additional space, so that's why it's order of 1. So let me go ahead and see if it is working as expected. So it's getting expected, so it's good. So yeah, that's the end of this video. Just let me know your thoughts, views, or some other ideas that you might have to improve this algorithm. Thank you guys, have a good one, bye.